Well, our last example of chapter 4 is going to use the inverse function theorem. This problem was taken from the textbook, and it says, let f be this polynomial. F of x is x cubed plus 2x squared minus x plus 1. Find an equation of the line that is tangent to the inverse function, f inverse, at 3, 1. Trust me, if we wanted to find the inverse of this function, that would be, I want to say impossible, but I'm just going to say it'd be very, very tough. But all we need to do is find the tangent line to the function at a particular point. Well, first of all, observe, this is just the definition, essentially, of an inverse function. 3, 1 is on this point, because we need to compute the tangent line. And that's true if and only if 1, 3 is on the function. You just switch the ordered pairs. And it obviously is. F of 1 is 1 plus 2 minus 1 plus 1, which is 3. So we could write this like f inverse of 3 is 1. F of 1 is equal to 3. Well, the equation, we're going to just write it in slope-intercept form. So all we need is m and b. We need the slope and the y-intercept. Well, I reminded us of what the intermediate value theorem says. Here's the formula for it. And I made a note here that the first thing we might as well get is the slope m. So we need the slope of f inverse at this point, which means we need f inverse prime evaluated at 3. Well, remember this. We need f inverse prime evaluated at 3. Well, the inverse function theorem has f inverse prime of, how do we get that to be a 3? F of what gives us 3? F of 1 is equal to 3. So all we need to do for this formula is plug in x equals 1. And we would get f inverse prime of, maybe first I'll write it like f of 1 is equal to 1 over f prime of 1. But f of 1 is 3, so f prime, or f inverse prime of 3 is equal to 1 over f prime of 1. So let's compute the f prime. That's easy to do. F prime of x is equal to 3x squared plus 4x minus 1. So f prime evaluated at 1 would be a 3 plus a 4 minus 1. F prime of 1 equals 6. All right, so this is 1 over 6. So the answer to that question, f inverse prime evaluated at 3, is 1/6. Now all we need is the b. So we know that the ordered pair 3, 1 is on f